Well, good afternoon, everyone. It's nice to meet the Commissioner in person. We've had our COVID virtual session before, but it's nice to put a face to the name. First, I'd like to thank the organizers of this great event to invite me. This is really an exciting thing for me to talk about. I know it's late in the afternoon. I stand between you and a beautiful afternoon out there and perhaps cocktail hour, so I'll be brief with my comments and careful. But, you know, we're living in a remarkable time right now. Not only are we kind of working our way through the end of the pandemic, but we're at the doorstep of this energy transition. And I wanted to kind of just say a few words about that because that term gets used differently by all kinds of different people. The way I think about the energy transition is about emerging markets. New markets that are appearing. Some of those are being created by policymakers. Some of those are being made by choices that customers are making. But these markets, we're starting to get signals in these marketplaces, and so companies are starting to position themselves to be able to take advantage of those markets. And when you look at the energy transition, a lot of people talk about their goals, their greenhouse gas emission goals, and certainly we're interested in helping Houston meet its 2050 greenhouse gas emission goals, but we're also interested in helping Houston win in the energy transition. How do you win in those markets? How do you stay competitive? How do you make sure that the energy capital for the last 100 years stays the energy capital for the next 100 years? And that's a little bit what I want to talk about here with my talk today. Let me first talk a little bit about this new part of the organization that ExxonMobil has created called Low Carbon Solutions. And the objective is pretty straightforward. We're trying to create new products and services that are going to demonstrably reduce greenhouse gas emissions, both for the company and our customers. And to do that, of course, we're going to have to do a lot of work advocating with policymakers for market-based approaches, market-based policy that's going to guide how those markets evolve. It's going to require an incredible amount of collaboration in industry, collaboration with communities, and collaboration with policymakers to make sure that the correct policies are set in place. So let me tell you a little bit about CCS, because that's kind of the underlying technology here. And we'll see if we've got a little video that runs while I talk about this. CCS is carbon capture and storage. It's a very straightforward idea. You're trying to capture the carbon that comes off of anthropogenic sources for emissions, whether that's industrial or manufacturing. Usually when you do that, you get hydrogen and you get CO2. So you start with methane, you use the methane, you get hydrogen, and you get CO2. You take the CO2 and you very safely put that down in the ground. Then you may or may not be able to use the hydrogen. That's the basic idea. It's a very simple and actually relatively old technology. It's something that we've been doing for decades. There's lots of experience by the company and by industry to do this. So now is the time where we need to kind of take all that experience and work it at scale. And that's what the Houston Hub idea is really about, is taking this to a whole different level of scale. Why do we need CCS? Well, it's really one of the only technologies that's going to help us decarbonize the heavy industrial sector, manufacturing and heavy industry. You know, and that we heard in the last panel, all of the essential products that this industry creates, whether it's the plastics to build an electric car, the lubes to put in a wind turbine, or as was mentioned, virtually anything you find in a hospital. That's all part of this very hard to abate sector. We don't have alternative ways to make those products for society without using petrochemicals. And so the most important thing we need to do to preserve that is to sequester the CO2 that comes off of those processes. And if we do that, we're producing carbon-free products, which in these evolving markets may demand premiums. So that's new businesses and new opportunities for us. Wind and solar are going to continue to play important roles in reducing emissions, and electric vehicles are going to help with the transportation sector, but those things are not going to help with the hard-to-abate petrochemical sector. So CCS is the essential technology that we need to apply at scale to reduce carbon emissions in that sector. This is a widely recognized fact, finally. It's got even the major organizations, the UN, the IPCC, the IEA, are both aligned that CCS is an absolutely essential technology towards meeting any of the greenhouse gas climate goals that countries are putting out. And in fact, the IEA said that reaching net zero is virtually impossible without CCS. ExxonMobil brings a lot of experience to this. As I've mentioned, we've been working on CCS for over 30 years, including the design, construction, and operation of CCS facilities all around the world. Since it was first deployed in the 70s, we've captured more anthropogenic or man-made CO2 than any other company in the world, and more than the next 4 companies combined. ExxonMobil was the first company to capture more than 120 million tons of CO2. That's the equivalent of all the annual emissions of 25 million cars, just to put it in scale. So we're an experienced player in this. We're very active. We've got a number of projects going on around the world. Currently, we have a capacity for CCS of about 9 million tons per year. Projects that are operating in the United States, Australia, and Qatar. In Canada, we just started a project at our Strathcona refinery that's going to use CCS as a part of a process to do renewable diesel fuel. And that facility will capture about 500,000 metric tons of CO2 per year. Here in the States, in Wyoming, at our LaBarge facility, we have the largest CCS operation in the world. That's 7 million metric tons of CO2 captured per year. Remember that number, 7 MTA. That's the largest current CCS project in the world. We've started permitting to expand that a little bit as well. And I'll talk about Houston here in my next slide, but also on this map you'll see that we're actively progressing projects in the UK, Belgium, the Netherlands, France, Singapore, and we have working interests in CCS operations in Qatar and Australia. So the bottom line is we have a lot of experience in it. It's been run for decades across the world. And now what's really exciting, I think, is that Houston is poised to take a real leadership position in the CCS world. For the past few years, even before we formed this new low carbon solutions part of the company, we've been studying CCS hubs in major industrial areas all around the world as a way to kind of increase the scale of what you're doing with CCS. And the industrial area around the Houston Ship Channel is just perfectly suited for a project like this. One, you've got an enormous number of point source emitters relatively close together, and then importantly, they're very close to a truly world-class sequestration area in the offshore Gulf of Mexico. So you don't have very much distance between between where the emissions are and where the sequestration is, which keeps the costs down pretty significantly. So the scale of what you can achieve here in Houston is unlike anything else in the world. And the project that we've kind of scoped out and put out as an idea, we envision something like 100 million, remember 7 was the largest in the world, 100 million metric tons per year being captured if we can gather up the emissions in the point sources of the greater Houston area. And we can do that by 2040. We could get halfway there by 2030. So this is a huge chunk of the greenhouse gas emission challenge that Houston can take on if it's coordinated and we work together. Just to give you a little bit of idea of scale, I'm not used to these numbers. As a geologist, I didn't really use hundreds of millions of tons of CO2 very often in my work. But just to calibrate you a little bit, 100 million tons per year of CO2 is like all of the cars in Texas per year being taken off the road. That's how much CO2 is. Or some people like to plant trees as a way to kind of decarbonize things. They'll do deep reforestation. That's like planting all of California in trees every year. So it's a huge chunk of a very tough problem that we can accomplish. But of course, as I mentioned, it's all about collaboration, and that's why I'm really excited with the announcement we made last week where we've got 11 companies now working together, all committed to the idea of advancing CCS in the greater Houston area. And just with these 11 companies alone, we're at about 75 million tons per year of sequestration capacity if we can work all those emissions. So we're well down the road, and we're talking to other people. I'm sure we'll be able to get other people to join in on us, join the group here with us and get to that 100 number. So you can see it's a wonderful group of quality organizations. They're going to bring all kinds of diverse skills and diverse viewpoints. And so we're really looking forward to working. This isn't an ExxonMobil project that they're joining. This is a joint project that we'll be working together with all of these parties on. And I think it's a really exciting opportunity for collaboration. I have to say, I've been working in the oil and gas industry for 30 years, mostly in the upstream. But I've never seen a project where we had 11 major companies come to work together on a single venture. It's really kind of an unprecedented thing, and if we get a few more joining us, this could be a tremendous thing. So I mentioned hydrogen. Let me just say a few brief words about hydrogen, because this is an exciting follow-along part of the CCS story. An added benefit when you do these large CCS hubs is that you produce more hydrogen. And when you pair that with CCS, the hydrogen's produced without any CO2 emissions. So you have low carbon hydrogen. And if you want to start a hydrogen economy, if you want to start hydrogen trucking or hydrogen shipping, then Houston becomes the epicenter for starting those kinds of companies, because you've got cheap, abundant, decarbonized hydrogen available to start those industries. And we're working with a variety of other companies to start piloting and looking at how do we get that industry going, how do we develop those industries and see if they can be competitive. Okay, so let me finally mention a few other additional benefits. One of the nice come-alongs with working and scrubbing CO2 out of the emissions is that the process by which you remove the CO2 from most of these emissions also scrubs particulates. So most of the SOx and NOx comes out. So you have a substantial opportunity to really improve the air quality of the greater Houston area, which of course is going to be a big concern for the local communities when you're working here. So it depends very much on, you're going to need additional power to do all of this CO2 removal, so it depends very much on where do you get the power and making sure that that's clean power too. But this is a huge benefit. And then of course there's enormous employment benefit here. We conservatively estimate many tens of thousands of jobs to execute the full 100 million ton per year sequestration project in the greater Houston area. But the National Petroleum Council has done a whole bunch of work on looking at this as a national exercise, because there's many places that you can run these kinds of hubs. And they've estimated that, jobs associated with CCS investment in the United States could grow from about 10,000 per year to more than 200,000 per year by 2050. So it's an area, again, where Houston can lead. We can start creating employment, creating the expertise in the professions, and then as that industry rolls across the greater Gulf Coast area and then into the country to create more of these hubs, Houston's leading that CCS industry to fruition. So the beginning of something really big. But as I said, it's going to take a lot of collaboration, and the other party that has to be involved in the collaboration are policy and lawmakers, because it's going to take a lot of capital. We'd estimate that the project will take something like $100 billion of capital to run. So you have to create mechanisms that all that capital is going to flow in to all these companies to be able to do the work, right? Nobody has $100 billion in the mattress right now. So a lot of capital moving. The only mechanism that we currently have to move capital in for CCS is a tax deduction called the 45Q. Some of you are probably familiar with it. And it's a fairly clunky vehicle for a very complicated problem. And right now it's set in a way that really wouldn't facilitate the movement of much money into a scheme like this. And so one of the primary advocacy points for most of the people that are interested in getting CCS rolling is getting adjustments to that 45Q number. We'll also need major investments, infrastructure investments from the government, probably in pipeline or maybe in the offshore sequestration area. The countries that are moving quickly on this, like in Europe, tend to have fairly substantial government direct investment into that infrastructure, either through grants or direct loans. And so that's going to be something that we'll probably need here in the States. And then there's a whole host of regulatory issues. Ironically, today, injecting CO2 into the ground is considered a waste. So it's pretty much, from a regulatory perspective, similar to injecting nuclear waste into the ground. So you have a relatively burdensome regulatory set of hoops that you have to jump through, and that'll have to be streamlined, obviously. Right now, the federal government doesn't actually have the right to grant pore space in the offshore to sequester CO2. So that'll have to change. And fortunately, in the current infrastructure bill, there is language in there that would correct that. And so that is one of the things that we might see some progress on in the current legislative cycle. Okay, so I think I'll kind of stop there and just refresh you with a few of the closing points. We're committed to reaching this goal of carbon neutrality that Houston has set by 2050. CCS can have a significant impact in reducing emissions, and it's one of the few proven technologies that could enable industry sectors to decarbonize, where our company is one of the leaders in CCS. We're very proud to be part of the 11 companies that have come forward and announced interest to advancing this technology. And last but not least, it's going to take a collaborative effort to make this happen. Industry, local, state, federal government, private investors, and most importantly, the communities that we operate in around Pasadena and the Ship Channel region. So I'm happy to take your questions on this. Very excited to be starting working on this project.
Thank you, Eric. We have a few questions, and folks have been voting some of them up, so I wanted to kind of run some of these at you. First is, what's the long-term economic and environmental benefit?
Yeah, okay, so the environmental benefit is twofold. You know, we've kind of hit on the CO2 reduction, so depending on where your feelings are about greenhouse gas emissions, it will substantially lower greenhouse gas emissions at a relatively low cost. So the way I kind of view that as a scientist is I say any substantial reduction that we can make at reasonable cost seems like that's helping us. Seems like that's a reasonable thing to be doing. So on the CO2 front, that's that. But I think for me, from a local perspective, and probably the more noticeable thing, about a third of the SOx, NOx, ozone problem that we have in the greater Houston area, and we do have a problem, about a third of that is from these point source emitting facilities that we're gathering up here. Most of it's from the road, you know, most of it's from us driving around and heavy trucking. So I think one of the most noticeable things that we could really take on is if we get the point source emissions cleaned up, that'll take care of SOx, NOx in a big way. And then if we can start creating a hydrogen trucking economy where some of the heavy duty trucking that's moving around the greater Houston area, like in delivery vehicles that are kind of coming back to base every day, you know, then that has the potential to bring the diesel input on SOx, NOx down too. So I think those would be the big environmental deals, and then economic, lots of jobs. And, you know, it's not just creation of jobs, but I think in that previous panel, they made this excellent point about the goods that you all create in these facilities around here are going to be made, you know, society is going to get those goods. The only question is, where are they going to be manufactured? Are we going to keep them here, or are we going to send them overseas somewhere? So it's a job preservation and a job creation tool if we do it right.
Good, good. A couple of kind of operational questions. So once you're able to secure and sequester the CO2, is it there forever? And do we anticipate maybe 50, 100 years from now there being a new technology that we can go back and possibly use that as a feedstock for something in the future?
You know, there's a lot of people looking at that question, a lot of researchers looking at how do you use CO2 as a product to build materials. And I think we're researching that, so that's something that's sort of decades away. The CO2 is generally going to go in two places. In our project, we envision that it's going to be permanently sequestered geologically. In other words, it's going to be put down deep, and it's very unlikely we'll ever see it again. You know, it'll go for sort of geologic storage. There's other ways in CCS where they use the CO2 in the production of oil in oil fields. It's called EOR, or you'll hear the term CCUS. And so that also has the benefit of generally putting the CO2 in the ground and keeping it there. You're just producing oil while you're doing that. For the project and the geography that we have, we generally see it more likely that most of the CO2 would be going offshore for permanent sequestration. But again, that's, you know, these companies that come together to work on them, that'll be their job to go out and figure out exactly what they want to do and what that project design looks like. So we've scoped it, but we'll just sit at the table as a member of those 11 companies and figure out what the right way to do it is.
So again, I couldn't remember if you touched on this. So if you mentioned deep. How deep? And then talk a little bit about maybe pipeline infrastructure to go out into the Gulf.
Yeah, great. So you know, there's a bunch of organizations that have looked at CCS. This has been kind of an academic topic for a couple decades. So there's a lot of research, a lot of the Bureau at Texas, the University of Texas has led and done a lot of great work. And one of the bodies of work that they've done is identifying the shallow Gulf of Mexico as one of the premier sequestration areas, not only in the United States, but on the planet. It's really extraordinary, and that's because it has this huge thickness of Miocene stands with a good cap rock on it. And there's all kinds of numbers, like you could store all of the emissions of the United States down there for 500 years. You know, it's a huge capacity for storage to put in there. So on the geology side, that's, you know, that's the idea, is that, you know, you're putting the stuff down there and it's staying down there. The second part to your question.
Pipeline infrastructure.
Oh, pipeline infrastructure, yeah. So again, this will be a really important topic, and a great thing about having all these companies come together, because we're all local and in the area and familiar with, you know, the local communities. But our initial scoping suggests that most, if not all, of the pipeline work that needs to be done to gather the CO2 can be done in existing easements.
Yeah.
So the idea is that, you know, I think at least initially you'd gather up all of this stuff and then go offshore with a single line and go into a sequestration, some kind of sequestration area offshore on a single line.
Well, and you touched a little bit on this, but one final question. Talking about partnerships, do you anticipate partnering with owner companies from around the greater Houston area, the Houston Port region, or just specifically EPCs, or EPCs and manufacturing facilities, you know, in the downstream side of business as well?
There's a lot of people that are interested in engaging in this process, and so I think that's going to be one of the very first activities of this group of companies that's come together, is to figure out how do we engage and keep informed all of the interested parties. So you can kind of see it as concentric circles. There's the emitters, the people whose emissions we're actually dealing with. They'll form a core of interested parties. Mm-hmm. And then you'll have you know, various supporting organizations, whether service organizations or community organizations or academic organizations, that'll be tied into that. But we realize that a key measure of success of this is going to be how you integrate and keep everybody informed and aligned and you know, engaged in the project. So that'll be a big part of the activity.
Very good. Well, it's forward thinking, it's bold, it's collaborative, and we really appreciate your leadership specifically, and ExxonMobil for their leadership in this as well. Let's give Erik another round of applause. Thank you so much, Erik.